Alrighty, folks. So we are going to go over 1b.3b, the second part of it, focusing on our correlational parts of experiment and study. Right. So far, we have talked about descriptive research, experimental research, and today we're going to focus on correlational research or correlational studies. The final research method that we're going to talk about. Big idea is that this one is going to be focusing on relationships. A correlation is a relationship between variables or two different things. So this is mostly studies that we can do through surveys or observations. You can even do so with experiment if you set it up. It's mostly showing correlations, but we cannot show cause and effect. Only correlation. We can only show connection. Okay. Big idea, if nothing else. Recall, if there's nothing else that I want you to know from correlation and experiment, it's that experiment is the only way we can show causation. Okay. A correlational study cannot show causation. It can show really tight connections, but it cannot show causation. So for instance, two things that are extremely correlated: sales of ice cream and shark attacks. Right? As sales of ice cream goes up, shark attacks also go up. As sales of ice cream go down, shark attacks go down. Right? Does that mean that if we sell more ice cream, there will be more shark attacks? No, of course not. That's insane. But what it means is that summer happens, which causes both more ice cream sales and shark attacks. Right? So we got to recognize that that correlation cannot be causation at all times. It can be at times, but we have to prove that with experiment. We cannot do it with just a correlational study. And that is true across so many different things, right? There's an entire website on this, my favorite of which is a very tight correlation between number of people who drown by falling in a pool, tightly correlated with the number of films that Nicolas Cage appears in. A correlation of 67%. Pretty solid correlation. Okay, pretty strong correlation between the two. Does that mean? No, of course it's not. I'm not even gonna ask the question. They aren't related at all. But for some reason, those that two things happen. There's not even like some other third thing causing these. It just meant that by chance, again, we perceive order in random events. These are two random events that happen to be correlated. It doesn't mean that there is causation. And you can find, I've got a link in here somewhere where you can find all of these. If you click on this study here, it'll teach you two spurious correlations. Basically correlations that aren't going to be actual causation, but we just assume that they are. So what is a correlation? Right? Like, what are we really looking at here? A correlation is the extent to which two variables are changing together. That's a relationship between these two things. And that's going to be expressed in either negative or positive form, right? So a negative correlation is when you've got two variables, one is going to increase while the other is going to decrease. So negative relationship, think of them as opposite, right? Oftentimes relationship, we think of like couples. I think we can think about it in a similar way there. If you're in a negative relationship, one variable or one member of the couple is growing, getting better, while the other is doing the opposite. They're growing apart. Okay, a negative relationship are where two things grow apart. One goes up and the other goes down, or vice versa. Whereas a positive correlation, okay, or a positive relationship between these two variables means that they're both either increasing or decreasing together. They're sticking together. Okay, meaning that their relationship is very much, they're dependent on each other, but one goes up and the other also goes up with it. Okay, or vice versa. So examples of each: positive correlation, we've talked about this one before, but the amount of time that you spend studying and GPA. Okay, if you flip that though, right? So that's a positive amount of time you spend studying and your GPA. If you study more, your GPA will go up, right? However, negative correlation, things that are opposite, the amount of time you spend watching Netflix, as that goes up, GPA on average goes down, right? Are these true for everyone? No, but they're true on average. Again, remember we're talking about sampling. If we get a large enough sample size, we can account for things like outliers. Like individuals who somehow watch 30 hours of Netflix every 2 days and still have a high GPA. But when we average it out across a large sample size or population, we can find that negative correlation holds true. So positive and negative correlation. Negative, the two things are moving opposite of each other. One goes up, the other goes down, or vice versa. Positive correlation means that they're both going up at the same time or they're both going down, that relationship. Okay? The way that we express this, the way that we write this down, the way that we would say how strong that correlation is, how tight the correlation is, the relationship, is through -1 to 1. So we are using that scale only, right? You're never going to have like a positive correlation of 7, okay? Your correlation here, correlation coefficient, is between -1 and the stronger that you get, the further away from 0 you get. Okay, so a strong correlation is either -1 or 1. That is a perfectly positive or a perfectly negative correlation. The weakest correlation is 0. That means there's no correlation whatsoever. There's no relationship between them. So as we move away from 0 in either direction, the correlation gets stronger, right? Because correlation can be positive or negative, right? That doesn't mean one is better or the other is bad. It just means that positive or negative, meaning that either they're tightly related in the same direction or they're tightly related in opposites. Okay, it's how much the movement of one changes the other. So correlation coefficient, if we start at 0, we're going to 1, be a very strong positive correlation. If we're going to -1, it's a very strong negative correlation. Okay, so 1 and -1 are the strongest correlations. All right. Don't look for that number, right? You're not going to get a lot of 1s and -1s. That is a perfect correlation. It almost never happens, right? Except in like, right? We're not going to get it in the real world almost ever. There's always going to be an outlier, right? The best correlation you can get is probably like a 0.9 or something like that. And of course, I'm going to point it out again. Correlation is not causation. It's on every slide for a reason. But what does that look like? Positive and negative correlations. And you're going to need to be able to see this, right? You're going to be able to see this and point it out and recognize what a positive and negative correlation looks like on a graph. Or if you are given the numbers even, you'd have to recognize and point out what the representation of that is. Or even sometimes you may have to predict if it's going to be a positive or negative correlation or what it's going to look like on a graph. So you need to be able to recognize this. So if there's something that has a perfect positive correlation, as one goes up, the other goes up on an XY axis, right? As the x-axis increases, the y-axis also increases, right? We see this perfect correlation right here, right? A perfect line in the upward direction, okay? That is a perfect positive correlation. On the flip side, though, a negative correlation, as one goes up, the other goes down. So, for instance, as the x-axis goes up, right, the x-axis is getting larger, we see the y-axis going down, right? X-axis is very low. It's like almost 0. The y is at 10. But as the x-axis works its way up to like 10, the y-axis drops to almost 0. Okay, so a negative correlation is going in the other direction. And you should be able to recognize this. You will probably get a question that's like, is this a positive or negative correlation? You've got to be able to think about that. Okay, so one goes up, the other goes up, positive. One goes up, the other goes down, negative. Okay? What you're likely going to see in psychology are things that look a little bit more like this. Okay, you're not going to get this perfect line ever. That's a math thing where you're actually drawing a line. These, what you're seeing, is a correlation that isn't going to be perfect, but can be stronger or weaker, right? So for instance, a very strong positive correlation looks like a line, right? It's not a perfect line, but it's pretty close to a line, right? A more moderate positive correlation is still a line, right? We still see that as x goes up, y is also going up. It's just not quite as tight to a line, right? It kind of spreads out a little bit, but it's still mostly moving up, right? So what I tend to like to do is try to draw like a line on the outside, draw a line on the bottom, and then try to line like right through the average in the middle. Pick those lines and see what direction they're going in. That'll help you to figure out if it's positive or negative. Okay, negative you can see along the bottom are the same thing. Moderate negative correlation is going to be like kind of spread out, but still as a whole, as one goes up, the other is going down. Strong correlation looks like that negative correlation line. And then a no correlation, there's not really a connection here, right? We can't really say that there's a like hint of a positive correlation, but it's just all over the place. It's just spread out, meaning that there's no correlation. We cannot say that we have anything strong there. Take a minute, think to yourself, which of these is going to be the strongest relationship? Okay, go back, watch the video again, look at your notes. Which one of these is going to be the strongest relationship? If we've got a correlational coefficient of A, B, C, or D here, which one would be the strongest? Done. Correct answer in this case is D. Now remember, absolute value, the strongest here is negative 0.91. That is a very, very strong negative correlation. 0.76 is a pretty moderate or good positive correlation, but it's not nearly as strong as negative 0.91. Doesn't matter if it's positive or negative. A strength is in how close it is to 1. Absolute values, negative 1 or 1 are our strongest, meaning that's how tight that correlation is either positive or negative. Final thing to focus on, this idea of illusory correlation is, there these correlations like ice cream sales and shark attacks that we see connections and our brain tries to perceive order in those. Remember, we perceive order in random events when there really isn't, right? Like Michael Scott saying, I'm not superstitious, but I'm a little bit stitious. We think that there is something when there's not, right? We'll notice something, we'll connect it to some other form of, or some other thing that's been similar to that in the past. We put together a pattern and we're like, I knew it. This is what caused it. So illusory correlation oftentimes kind of makes us believe superstitions, right? So Michael Jordan, right, a local UNC hero. One of the more famous examples of illusory correlations or superstitions in sports. They talk about this in Space Jam, and you can see it in that picture there. He always wore, for the first couple seasons, he would always wear his UNC shorts, his UNC practice shorts underneath his shorts when he played for the Bulls, right? He thought that the shorts brought him good luck, right? He was like, I have to wear these, right? After playing really, really well in the playoffs with them one year, he decided for the rest of his career he was going to wear them. And I don't think he wore them for the rest of his career, but in the early days, he like absolutely had to have his shorts every time he played. And so there's no telling how gross those things were, but he thought that there was a connection, and it's classic in sports. Many people do. You see like the rally caps. Everybody turns their hats inside out. They think that that's going to bring them good luck. And this is not just in sports, but like other superstitions. Like we see a connection between full moon and behavior. Ask any teacher, and every teacher will make this claim. They'll be like, it must be a full moon. The kids are acting crazy. Right? There's no actual connections there. But if a kid acts crazy on the full moon, one kid acts out, we're like, I knew it. I knew it. There is a correlation, and therefore the full moon is causing this bad behavior. It's not. But right, we assume there is. We look for that connection when there really isn't one. That's an illusory correlation. You see some small connections, and we assume that, but there's not actually. Finally, big ideas of 1b.3 or correlational studies is that correlation showing relationship between two variables, right? They're either positive or negative. Positive meaning both of those are going up at the same time. Negative meaning that as one goes up, the other goes down, right? So you've got to remember what that looks like on a graph. You got to be able to pick that out, or even in some cases map it out yourself. Correlations are the coefficient is scored between -1 and 1. Use absolute value to figure out how strong that is. Okay, so a -1 or a 1 correlation is the strongest. And then finally, be aware of and weary of illusory correlations, right? We see some form of connection. When I wear these shorts, I play better, right? It's probably not the shorts. Maybe there's some placebo happening, but clearly a pair of shorts is not going to, right, make you any better than the like professional pair of shorts that you would be wearing, right? But you think there is, and maybe that is any evidence that you have is going to make you believe that, right? So correlation without causation, it leads us to assume that. All right, we're going to call it a day there. Answer all the questions, use this. This should be good enough now for you to fill out any essential questions that you might have. As always, if you have any questions, reach out. But with that, I will say peace and much love.